The SKILL programming language allows you to create user-defined procedures that allow you to create reusable blocks of code. Let's open our example from a previous video. This example used a let function to create a block of code that will calculate the distance between 2 points in x1, y1, and x2, y2. The result of the let block was stored in the variable distance. To make this code more reusable, we'll create a user-defined function named distance that could be reused just like any other SKILL function. We use the procedure function to create a user-defined function named distance, and our procedure will encapsulate our entire let function. It is common for the entire contents of a user-defined function to be encapsulated in a let function, so that local variables can be used. The procedure function is just like other SKILL functions, so you cannot have a space after procedure and before the opening parentheses. Also note that we included another open and closed parentheses. This is where we would include any parameters that must be passed to our user-defined procedure. We will use parameters to improve the reusability of our user-defined procedure in just a little while. Let's get rid of 2 of our print statements and then save and load our file. When the file is loaded, the distance procedure is not run. It is only defined, and can now be used just like any other SKILL function, and we can run it as many times as we want, reusing the code over and over again. Unfortunately, our code only calculates the distance for the point that was defined in our procedure. Let's pass x1, x2, y1 and y2 as arguments to our distance procedure, to make it a more convenient and reusable function. First we'll remove x1, x2, y1 and y2 as local variables to our let function, and include them as parameters to our distance procedure. For completeness, we'll also add delta x and delta y as local variables to our let function, so we do not accidentally change the value of these variables if they happen to be used outside the scope of our user-defined procedure. Let's save and reload our file to redefine our distance function. Our distance function now requires 4 arguments, and if we do not supply the correct number of arguments, then an error will occur. The arguments are position-based, so the first argument is always x1 followed by x2, y1 and y2. Arguments are passed by value, so we can supply the arguments as literal numbers, or we can assign values to variables, and the variables will be evaluated to their values before being passed to the distance function. It is worth noting that the built-in SKILL data types such as integers, floating point numbers, and strings are passed by value. This means that if the value of the argument is changed in a procedure, that value change is not reflected back at the higher scope outside of the procedure. For the sake of example, at the end of our distance procedure, let's change the value of the x1 variable to a string and print its value. If we save and reload the file, the procedure is redefined. And when we run the distance procedure, we see that even though the value of x1 is changed in our procedure, the scope of the change was local to our procedure, and after the procedure is run, the global value of x1 variable is reused. The return value of a procedure is the last expression evaluated in that procedure. As we can see from our example, you do not need to explicitly return a value from your user-defined functions. All your user-defined functions will return the last expression in your user-defined function. In our case, the last expression is the let function, and the return value of the function is the last expression in the let function, so the return value of our user-defined function is the return value of the sqrt function that calculates our distance. If we had inadvertently put our print function after the sqrt function, then it becomes the last expression in our let function, and therefore the return value of our user-defined function. Since the print function always returns a t, our distance function will now return t, even after calculating our distance. In summary, you can use the procedure function to create user-defined functions, which are reusable blocks of named code that can accept any number of arguments that you define.